So simple harmonic motion, and it is very simple motion. We're just talking about a particle. It just moves backwards and forwards, and that's all it does, but in a very particular way. Its acceleration at any instant is proportional to its distance from some fixed point. So let's start with that idea. Acceleration is proportional to displacement. Now, if it's directly proportional, then we know it's equal to some constant. But in order for this to work, that constant needs to be a negative number. So we force it to be a negative number by making it minus n squared. Then we're guaranteed to have a negative constant. So that's the first thing we know about simple harmonic motion. It has to satisfy this equation. At any point in time, its acceleration is equal to some negative constant times its displacement. That therefore means that v to v dx is minus n squared x. Separate out our variables. Now, I haven't been given any initial conditions, so I'm going to just give it the initial condition that we're going to start out at the end point. And it's just going between 2 points, backwards and forwards, backwards and forwards. So I'm just saying, well, look, out at the end point. Now, why did I pick there? Well, because I know it has to stop at that point to then turn around and come back. So that's why I've chosen that point. So velocity will equal 0 out at its end point, which I've called A. I want to find an equation that links v and x, velocity and displacement. Okay, so I integrate both of those. Now A actually is going to represent the amplitude of our motion, and that's why I called it A. So v squared will equal n squared a squared minus x squared when I substitute in. Therefore v is plus or minus n the square root of a squared minus x squared. What does that tell me? Remember, v squared has to be greater than or equal to 0, or another way of thinking about it, whatever's under that square root sign has to be positive. If I was to solve that, then I get, there it is, x is travelling in between these 2 points, and it's nice and symmetric. It goes out to a at one end and then out to negative a at the other end, and the centre of the motion would be 0. It travels backwards and forwards like so. Okay, well, let's try and get our displacement time equation. Velocity is dx to t. I've taken the negative. Now why? I've got to match the initial conditions, but in this case, the initial conditions were that velocity was 0. So it actually didn't matter whether I took plus or minus. So why did I choose minus? You see, I'm going to end up integrating. I'm going to end up with a trig function. So I want the motion to match the trig function. Now at 0, which trig function is out of its amplitude? What's the cosine function? So that's why I chose the negative one. It's going to make my integration a lot easier. If I had started at the centre of the motion, then I would have chosen positive, because then that would match the sine function. So flip it upside down, and there it is, minus 1 on root a squared minus x squared. There's our standard integral, which would either give me sine or cosine, depending on which one I choose. So I went with negative, I'm going to go with cosine. So when I integrate that, there it is, the inverse cos of x on a. Okay, playing around with it, substituting in those values. I've now got t in terms of x. Let's make x the subject, and we just get this beautiful cosine curve. And we know a lot about cosine curves already. But because of the way I've chosen my variables, it's a very simple cosine curve. There's the amplitude a, and then the angle is just n times t. Okay, in general then. We know acceleration equals minus n squared x, and sometimes they'll ask us to prove the motion is undergoing simple harmonic motion. Well, that's what we've basically got to prove. We've got to show that its acceleration can be written as minus n squared x. We came up with this one, v squared equals n squared a squared minus x squared. Some people memorise it and use it. I personally don't. That's why I haven't boxed it, because I think you can just derive these things just as easily. But that would allow you to find the path of the particle. That was the one where we said, oh, well, v squared is greater than or equal to 0, so that will give us the path of the particle. But then the other thing we know is it's going to be a trig function. So depending on the problem, I know it's going to look like x equals a cos nt or a sin nt, just depending on which one I've picked for the problem. A is the amplitude. The particle, well, because it's a trig function, makes life easy, the period of the particle is 2 pi on n, the trig function. But then it has this other thing called frequency, and frequency is simply the reciprocal of the period. So what is period? The time it takes for one complete oscillation, the time it takes to complete a period. So backwards and forwards, one oscillation. Whereas what is frequency, that's the number of oscillations you would have in a particular time period, whatever units you're using. And we're usually using seconds, but it could be any time that we're using for our problem. Okay, let's look at some questions then. Particle P, there it is. They've given us the trig function. They've given us the displacement time. And there's that standard sort of question. Okay, well, prove it is simple harmonic motion. So all I've got to do is differentiate it a couple of times and show that, look, my acceleration is a negative constant times my displacement. That satisfies our rule that we know. So yes, it's in that form, so it does move in simple harmonic motion. It asks us to work out the period, so 2 pi on 3 is the period, but of course we're talking about seconds in our problem. Find the interval in which the particle moves. This is why I say, well, I don't need that formula v squared equals n squared and so on, because I know about trig. So the interval in which it moves, well, you told me it's this trig function. And I know that trig function goes between 4 and minus 4. So there it is. And greatest speed, well, there's the velocity equation. It's a cosine. Well, the biggest that's ever going to be is 12. And I can just read it from the trig functions. This time they give me the acceleration one. So find the interval in which the particle moves. Okay, some people go, oh, let's use the v squared equals n squared and so on. Whereas I say, well, no, let's just do the calculus. V to v dx is minus 4x. So I'll integrate both sides once I've separated my variables, and it comes out. There is that formula, n squared minus whatever that formula is, I always forget it. Minus 4x squared plus 72 has to be greater than or equal to 0. So I'm travelling in between minus 3 root 2 and 3 root 2. And determine the greatest acceleration. Okay, we'll now go back. Well, acceleration is minus 4x. So its greatest acceleration has got to be when x is the greatest, and x is the greatest is 3 root 2. Wow, negative 12 root 2 or 12 root 2. I'll probably go with a positive because they're saying greatest. 12 root 2 centimetres per second squared. Let's have a look at some HSC ones. This one was quite nice actually, because a particle is moving in a straight line according to this equation. Prove it's simple harmonic motion. And they even told you, oh, look, show it's this. Acceleration equals minus n squared times x. There might be some shift, but at the end of the day, it's still minus n squared times x. Okay, it's got some constant as well. Let's look at this thing. I can make life easier for myself. You see, anytime I see cos and sine and the angle's the same, I know I can combine those into one trig function. This 6 cos 2t plus 8 sine 2t, hypotenuse would be 10. I know it's going to be 10 sine 2t plus alpha, and alpha would be the inverse tan of 3/4. So now I know I could rewrite x like so. And that's a little bit easier. I'll differentiate that a couple of times, and yeah, that is minus 4, and the shift that's happening here is 5. So the centre of motion here is not necessarily going to be at the origin. We've shifted the problem a lot. But it is in that form, minus n squared x. So we've got minus n squared times x. Now, when is the displacement of the particle 0 for the first time? All right, in other words, let's go and solve that equation. Okay, trig equation to solve. Again, because I've combined it into one trig function, it becomes an easier trig function to solve. And that's 1.5108. So it's first at 0 after 1.5 seconds. Here's our path of the particle. It's going backwards and forwards between 2 points. At the amplitude, velocity equals 0, because it has to stop, turn around, and go back the other way. So we know that. But it's also going to be when acceleration is a maximum, because acceleration was proportional to the displacement. So maximum displacement would have to give you maximum acceleration. At the centre of the motion, it must be the other way around. Velocity will turn out to be a maximum, but acceleration will be 0 at that point, because it's proportional to the displacement, or displacement is 0, and so on. So basically you're talking about this particle. Let's say I'm starting here. As soon as my displacement is positive, my acceleration, remember, is a negative constant. So acceleration is in the opposite direction to which I'm moving, so I'm slowing down. So I start, but I'm slowing down, I'm slowing down, I'm slowing down, I'm slowing down. I get to the amplitude, I stop. But now I'm turning around and going back the other way. Acceleration now is in the same direction as which I'm traveling. So I'm speeding up, I'm speeding up, I'm speeding up, I'm speeding up, I'm speeding up. I get to the center of the motion. As soon as I go past the center of the motion, then my acceleration goes in the opposite direction. So now I'm slowing down, slowing down, slowing down, slowing down. Stop, turn around. That is why velocity has to be a maximum at the center, because as soon as we go through the center, the acceleration changes direction. So I start slowing down. Let's have a look at some more recent ones. Since they put it into extension 2, remember it used to be an extension 1 topic, simple harmonic motion. They decided to put it in extension 2, so we get some nice little twists now with these questions. So let's have a look at a couple. The very first year it was in extension 2 was 2020. So particle undergoing simple harmonic motion, they've given us the period, they've told us the central point of the motion is not at the origin, it's at root 3. And at that time, it has a maximum displacement of 2 root 3 from its central point. In other words, it's not starting at that center, it's starting 2 root 3 away from it. We have to work out the equation for the displacement, and I'm just a huge fan of drawing pictures to try and get my head around what it's saying. I'm used to the center being at 0, but this one's not. It's at x equals root 3, so that is the center of my motion. But they told me it has a maximum displacement of 2 root 3 from the center point of the motion. Therefore, it must go out to 3 root 3 on this side, and on the left-hand side, it's out to minus root 3. Okay. The particle starts at the amplitude, because they said when t equals 0, it has maximum displacement. So that's out of the amplitude. So I know it's going to be a cosine function. So the standard cosine function, but there is a shift happening because we're not at the center. So plus a constant, there's our center. Okay, let's work out these things. They told me the period was pi on 3. So 2 pi on n is pi on 3. I now know n is 6. The center has been shifted root 3. So I know c is root 3. And 2 root 3 is our amplitude. That's what they told us. So I can just sub that in. Bang! There's the answer. X equals 2 root 3 cos 6t plus root 3. 2021 then, the next year, what did they do? Objects moving in simple harmonic motion, they gave us the acceleration displacement equation. Initially the object's 5.5 to the right, and has a speed of 8 meters per second as it passes through the origin. So what do they want us to do? Basically they're saying find the path of the particle, between which values is the particle oscillating. Well, I'll start with what they've given me. Acceleration is minus 4, x minus 3. So v to v dx. Separate out my variables. They've told me that when x equals 0, v equals 8, and we're trying to link v and x here. A bit of integration, and we have our equation. But we know v squared has to be greater than or equal to 0. Solve this quadratic, we'll get the path of the particle. So I know x minus 3 is in between minus 5 and 5, so x is in between minus 2 and 8. Find the first value of t for which x is 0. Now, make sure you use your reference sheet, okay? Like it's there. These formulas are there to remind you. So I know acceleration is equal to minus n squared x minus c. Simple harmonic motion. So therefore, because remember they gave me an equation, I know n is 2 and c is 3 for our problem. Also on the reference sheet, they then say, well, hang on, that means your displacement time. So I don't have to go and derive it all for this problem. I can just use the information they've given me in the reference sheet. So x is equal to a cos nt plus alpha plus a constant. Well, from part A, we know the amplitude is 5. We said it was going in between minus 2 and 8. So the amplitude is 5. Overall, it's got a path of 10. So chop that in half, there's my amplitude, 5. I now have my equation. Well, what's alpha? Well, we know that when t equals 0, x is 11 on 2. They told us that. So 11 on 2, I can now work out alpha. Alpha turns out to be pi on 3. They want to know when x is equal to 0 for the first time. We've got to solve this equation. So 2t plus pi on 3 is 2.214. So 2t is 1.167 we have t. Just be careful with these ones that you are getting the first value, because when we've got the shift here we're going to subtract pi on 3. Does that turn it to be negative? Those sorts of things you've got to watch out for. Okay, this was a nice one. 2022 question to combine sort of what we've been looking at in simple harmonic motion with some other ideas as well. So the diagram shows two positions of a single piston in the chamber of a motorcycle. Piston moves vertically in simple harmonic motion. They've given us the maximum height, the minimum height. The mass of the piston they've given us 0.8, and it completes 40 cycles per second. What is the resultant force on the piston in newtons that produces the maximum acceleration of the piston? And this is one of these ones where it wasn't in parts. You've got to put it all together. So, okay, here's what I did. They told me maximum height was 0.17. So I've just drawn a line and gone, okay, it goes up 0.17. I know that. It said the minimum height was 0.05. So I now know my piston is going between these two values. It tells me the path of the particle, the piston, is 0.12. Well, that tells me the amplitude of my trig function that I'm looking for is 0.06 for the simple harmonic motion part. And that's 0.11 above the ground there. Well, I'm calling it the ground. But the centre of the motion then is sitting at 0.11. 0.05 plus the amplitude gives me 0.11. Another bit of information they gave me. Frequency was 40 cycles per second, but frequency is the reciprocal of period, so I now know the period is 1 on 40. I can work out n. N is now 80 pi. Therefore, I know acceleration is minus n squared x. But we've got a shift happening here. So for R1, acceleration will be minus n squared, so 80 pi squared, 6,400 pi squared, x minus the centre, which I've worked out to be 0.11. There is my equation. Now, remember what they've actually asked us to find. The resultant force on the piston that produces the maximum acceleration. Well, maximum acceleration I know will occur at the amplitude. So in other words, when x equals 0.05, or I suppose I could have picked the other end point, I just chose the 0.05. So the acceleration, the maximum acceleration, I'll substitute that value in, I now know it's 384 pi squared. But force is mass times acceleration, and the mass of the piston was 0.8. 3,032 newtons will produce the maximum acceleration. So this one combined the simple harmonic motion, but with the idea of the forces mass times acceleration we've been looking at as well. So you had to tie it all together to get this particular one. Now in 6b, you'll find that these are the ones that start with the trig equation, and then you go and prove simple harmonic motion, or they might be told it's simple harmonic motion. Whereas 6 is the other way around, where you start with acceleration and work with that one.